Okay, we are talking about rational numbers today where I'm actually going to define what a rational number is. You're not going to have to identify today, but you are going to have to work with rational numbers. So you're going to be able to evaluate rationals and compare rationals today. You're not going to identify today. That is, I think, tomorrow-ish. But a rational number, I want you to box off the word ratio. A rational number looks like a ratio. A ratio looks like a fraction. So a rational number is any number that can be written as a fraction, also known as ratio. For example, 0.4 is rational because 0.4 can be written as a fraction, 4/10, 2/5. 3/8 is rational because it's a fraction. 5 is rational because it can be written as a fraction, 5/1. So anything you can write as a fraction is a rational number. So now that we're talking about fractions, we need to know how to work with fractions. We dealt with it yesterday when we were doing the simplifying the fractions. Now we're going to identify equivalent fractions. Equivalent fractions, let's see, you can multiply or divide the numerator and denominator by the same integer. Notice I wrote integer. Integer doesn't just mean a positive number. Integer means it can either be positive or negative. That's easy enough. Fractions never look that great, but it's easy enough. So, I'm going to write 3 equivalent fractions to the given, 1/4. Alright, so I'm going to times them both. Be nice to yourself. 10 is easy. So I can create an equivalent fraction of 10/40. But don't do 100 next and then 1,000 and then 1,000,000. Be nice. But do the 10/40. You know what another easy one is? -1. If I times through by -1, I get -1/4. That is equivalent to 1/4. Another easy one, of course, is 2. 2/8. Okay, -10/35. I'm going to do my easy one with a multiple of 10. So this would be -100/350. I am going to simplify the fraction because that's equivalent. So I can divide both of these by 5, and I get -2/7. That's equivalent. And you don't have to have the same as me. Please note, equivalent fraction, as long as you do the same strategy, you can get the same answer. And then I'm going to use the other one where I am timesing by -1. So that would be a +10 and a -35. All equivalent. 2/3, 20/30, 4/6, -2/-3. Okay? Not the only ones. You could have 10/15 if you wanted. You could have 12/18 if you wanted, as long as you followed the same strategy. Now here's the doozy. Yep, this little doozy. It's equivalent fractions with a negative sign. Now I've already kind of showed you it in the beginning examples. I forgot to show last year's kids and they messed this up. There's 2 questions like this on your assessment that you're going to get, and it says identify which fraction is equivalent to blah, and it's just the negative sign moving around. Here's the thing about the negative. It can go on the top, it can go on the bottom, or it can go on the side. As the key thing is that there's only one. Because if there's 2, it cancels out and you're left with no negatives. So that's the key thing. So -3/4 I can write as 2 more ways. A negative on the outside, that's the sign, and then a 3/4. That's equivalent. Or I can put the negative on the bottom. 3 over negative 4. Those are all equivalent ways to deal with a negative number. All right, now I have for negative 1/2. Negative 1/2, the negative's on the left-hand side. I can also put the negative on the top, negative 1 over 2. And I can put it on the bottom, 1 over negative 2. Those are all equivalent statements. They mean the exact same thing. So that's part A here, is that you can develop equivalent statements, okay? Fractions, rational numbers. Next thing, second learning target, don't write that down because that looks messy next to the other two. You have comparing and ordering. You want to get into the same form and then compare. So I want to order negative 1/2, negative 4/10, negative 2, and 0.9. So I like to get them all in decimal form. This is negative 0.5, negative 0.4, and that's all I had to change. Okay, now remember, the more negatives you have, the smaller you are. So what has the most negatives? 2. 2 has the most negatives, so that's the smallest number. The next one that has the most negatives would be the 0.5. So I would write negative 1/2. Always put it back in the original way. I know it's 0.5, but they gave it to me as the half. And then negative 4/10, followed by 0.9. You get to do that today.
Yay.
Yes. Thanks. Okay, negative 0.8, converting my fraction to a decimal. 1/2, converting my fraction to a decimal. Bigger the negative, the smaller you are. I have more, 0.8 has more negatives than the 0.2 negatives. So it'd be negative 8/10, followed by your negative 0.2, followed by 1/2, followed by 1. Okay, this next data set, I am just converting everything to a decimal. 1/6, I'm going 1 divided by 6 in my calculator, and I get 0.17 rounded. Okay, 0.17 rounded. And then 5/12, I'm going 5 divided by 12 is 0.42 rounded. Go in sequential order. My smallest number is my 0.42. Nope, just kidding, it's my 1/6. And then my 0.42, which is 5/12. And then my 2/3, followed by my 1. The biggest thing, get them in like form, if that helps you, and then make sure that you put it back the original way that it was given to you. When you're comparing two fractions, you can get common denominators if that's what you want to do. I don't usually do that. Like you could turn them both into 35s and then compare your numerators. I'm going to convert it to a decimal since I can use my calculator. It's way easier. So 6 divided by 7 is 0.86, and this is 0.8. So 6/7 is bigger. And you can think logically about that too. They're both 1 away from their whole, which is the denominator. 7 is bigger than the whole of 5. So you can think like that too. They're both 1 away from the whole, but the 7 has the bigger whole than the 5 does. Again, that same strategy would work with 2/3 and 3/4. They're both 1 away from their whole, but 4 has a bigger whole than the 3 does. Okay? Okay, so then 3/4 would be larger than 2/3. Now my negatives, I am converting to decimal just to help clear my mind. then remember the more negatives you have, the smaller you are. So 0.75 has more negatives, it is the smaller number. All right, last 3 examples. This is the actual application. We're going to evaluate. That means plug the numbers in and then simplify. That's the fun part of this lesson. I like evaluating better than ordering personally. So we're going to evaluate the following. For A is 6 and B is negative 5. Then we're going to write it in simplest form. Okay, so A plus B, which is 6 plus negative 5 all over negative 3. 6 plus a negative 5 is 1 over negative 3. And now that I showed you equivalence with negatives, we like to pull that out to the side. That's just what mathematicians do. They throw the negative. If the negative's on the bottom, they bring it to the side. Okay, the next one there's one like this on the test that lots of kids mess up. 7 minus B. B is negative 5. So 7 minus a negative 5. All over 3 times 8, which is 6. What does minus the negative turn to? Plus plus. 7 plus plus 5 is 12 over 18, which is 2 over 3. A plus 9 over B. 6 plus 9 over negative 5. 15 over negative 5. Hey, it's division. A fraction represents division. That's really what it is. 15 divided by negative 5 is negative 3. And we are done.